Bismillahirrahmanirrahim. Dear students, this is second year class. The chapter number 14 already started, and we are talking about the coordination compounds or complexes. So today in this lecture, we are going to discuss the shapes of complexes. Shapes of complex ions with coordination number 2, 4 and 6. Shapes of complex ions with coordination number 2, 4 and 6. This is grade 12 and article number 4.23. Article number 4.23. After the nomenclature of complexes. After the nomenclature of the complexes, if you see your book, open the book 14.23 article, and I am again repeating this, shapes of complexes, complex ion with coordination number 2, 4 and 6. So the coordination number shown by the pattern in the complex is 2 to 9. The most common are 2, 3 and 6. So geometries corresponding to coordination number 2, 4 and 6 we have to discuss. So number one we are going to discuss coordination number 2. The complex ion with coordination number 2, CN coordination, CN coordination number 2. So only the two ligands are going to surround the central metal ion or atom, two only. So when the two ligands are surrounding, the geometry of the complex ion or complex is linear. It shows a linear geometry. The geometry of the complex will be linear if there are two coordination numbers. Just like you have a copper ion and silver ion, and there are many other also geometries. Just like this is the square bracket, already I told you, copper, ammonia, like this one. This is a cuprous. This is a cuprous positive one. Diamine copper 1. So this shows a linear geometry. Silver, cyanide. So there will be a negative one charge on cyanide. There are two negative, two single positives should be negative one. So dicyano argentum. So we have to add ATE, argentum 8. Argentum 8 or silver 8. So you have, because this is the negative ligand, so that's why you have to write ATE in the last. And this one is a neutral ligand, so no need for adding. So this one is called diamine copper 1, and this one is called dicyano silverate 1 or argentum 8 1. Oxidation number of silver is 1. And also there are many other gold. Like this one. these complex show a linear geometry because coordination number is only two coordination numbers. Second one is the geometry of the complexes which have four coordination number. Four coordination number. Coordination number 4. So dear students, if you see the complexes, they have the four coordination numbers. So examples are given: square bracket, zinc, small bracket, or if there is a simple radical, then no need for giving the bracket. This is a Cl, which is a simple radical. No need giving the bracket here, small bracket. So chlorine is a negative 1. Negative 1 multiplied by 4, negative 4 and 2. So there should be a negative 2 here. So 4 ligands are here. Copper again. And there are 4 cyanides. Negative 1 multiplied by 4, negative 4 and positive 2, you will get negative 2. This is another example. Mercury. There is the mercury, and again there is a cyanide, and there are 4, and also here negative 2. So there is also another one, zinc and ammonia. There are 4. Here should be positive 2, not negative 2. This should be a positive 2, not negative. Zinc has a positive 2 oxidation number. Ammonia is neutral, so tetraamine zinc 2 and tetrachloro zincate 2, tetracyanocuprate 2, tetracyano mercurate 2 or hydrogenate 2, hydrocerium. Mercury is a hydrocerium. So these are the complexes, and they show the 4 coordination numbers. So dear students, if they have a 4 coordination numbers, so there are 2 possibilities. There are 2 possibilities for their geometry. Maybe the tetrahedral and maybe the square planar. Maybe tetrahedral, metal is center, and this is the ligand 1, and this is a ligand 2, this one is a ligand 3, and this one is a ligand 4. So if you are going to join these, so you will get this one NL4. This geometry is called tetrahedral. So tetrahedral geometry is going to be formed here. Tetrahedral. So this is the one possibility if there are 4 ligands are here. Or so if you have again same metal is center. So you have this ligand, like this one, this ligand, like this one, this one. Yes. So this one is the square planar, 90 degree, 90 degree, and 90 degree. This geometry is again square planar. Square planar ML4. So dear students, you are seeing that these geometries are for the coordination number 4. So possibilities, maybe they form tetrahedral structure, maybe they form square planar. So complexity with the coordination number 4 may be tetrahedral or square planar geometry. Complex like these, which I have already written, they shows tetrahedral structure. These show tetrahedral structures. Tetrahedral. These complex show tetrahedral geometries. And these are the for tetrahedral. Note. According to the examples in your book, so a square planar geometry is found in complexes of square planar. These examples I am going to say square planar given in your book. Nickel and ammonia 4. There is a +2. Tetraamine nickel 2. Tetraamine nickel 2. And cyanide -2. Tetracyanonyclate 2. Tetracyanonyclate 2. Platinum amine. Tetraamine platinum 2. Tetraamine platinum 2. Gold. Simple radical again. Tetrachloro iron. Gold is iron. So iron 8 because this is a negative ligand. So on the coordination sphere, if the negative charge is there, then you have to put the APE. So tetrachloroaromatic, the oxidation number of gold is 3. So aromate 3. So these are some examples I have written from the book. They show maybe square planar geometries. And the previous which I wrote, maybe they give the tetrahedral geometries. So dear students, again I am going to repeat this. The coordination complexes which have 4 coordination numbers, they may give tetrahedral geometry and they may give the square planar geometry according to their properties. These are the 4 coordination complexes. 4 coordination number. Note it. Now, coordination number 6. 6 coordination number. The complexes which have 6 coordination number. Like this. So how many? 6 coordination number. So students, complexes coordination number 6 are the most common ones formed by the transition metal ions. 6 ligands in the 6 coordination compounds may be arranged around a central metal ion or central metal atom, either at the corners, of hexagonal. Hex means six corners, hexagonal. Plane or axis of trigonal prism. Trigonal prismatic, we call trigonal prism, or at the axis of regular octahedron. So there are three possibilities. Number one is called a hexagonal. Number two is called trigonal prismatic. Number three is called octahedron. So you have, students, three choices. Number one is hexagonal. Baby. Number two is trigonal prismatic. Number three, octahedron. So these are the three possibilities for the structures. The complexes contain 6 coordination number. Now, if you see the possibilities which have more possibility, so according to explanation, these arrangements together with the numbers of designating substitution position may be depicted by these diagrams you can see here. Now here this is the point you have to note. Very important point, you have to note this one. An extensive study of the geometrical and optical isomerism of complexes containing coordination number 6. Extensive study of the geometrical and optical isomerism or isomers of complexes containing coordination number 6 has, however, shown the arrangement of 6 ligands. There are 6 ligands, I told you, because coordination number is 6, is always, he said always, mind it, always octahedron. Always octahedron. Always extensive study. According to optical isomerism geometry of the 6 contained coordination number, the geometry of the complex is always octahedron, and the argument concerning other possible geometries, argument for different scientists, different ideas, maybe the hexagonal and maybe the trigonal prismatic. Some arguments suggest, but always is octahedron. But some arguments suggest that maybe these geometries are formed by the 6 coordination number complexes, hexagonal and also trigonal prismatic, but always is octahedron. Or the historical. So the examples which are given here, I will write. This is the square bracket, cobalt, hexafluorocobaltrate 3. Hexafluoro. The oxidation number of cobalt is +3. Fluoride has a -1. So -1 multiplied by 6, -6, +3, -3. So hexafluorocobaltrate 3. Always octahedral, but some studies suggest that maybe these two geometries are going to be formed. So this is the number 1 example, and number 2 is copper, water 6, +2. Hexa aqua, neutral ligand. This is a neutral ligand. Hexa aqua copper 2. Hexa aqua copper 2. So this is the hexa aqua copper 2. There are again 6 ligands are surrounding towards the central metal ion. So the always geometry is octahedral. So students, these are the example I have written. So geometry, if you see in your book, so this is the metal here, and this is the one like this one. 1, 2, 3, 4, 5, 6. This is hexagonal. This one is a hexagonal. And this is the metal, and 1, and this is 1, and this is the 2, and this is the 3, and this is the 4, and this one is the 5, this one is the 6. So this one is called trigonal prismatic. Trigonal prismatic geometry. This one is called hexagonal, and another one is called this one. This is a, if you put here also, so there are, this is octahedral. 1, 2, 3, and this is a 6, 4, 5, 6. So this shows regular octahedral geometry. So there are 3 possibilities for the 6 coordination number complexes. So students, these were the 2, 4, 6 coordination number. They have different geometries. So now we are going to finish this chapter. Now students, I told you that if you visit the laboratory, maybe in the previous lectures I told you if you visit the laboratory, you will find different colored compounds. So if there are colored compounds, mostly they are transition metal compounds. So written here, color of the complexes. Color of the complexes are going to start another topic. Shades of the complexes is going to be complete. Now color. Color of the complexes. Color of the complexes. So when white light is allowed to fall on the complex, the following things may occur. Number one, the complex may absorb the whole white light. When the complex absorbs whole white light, then in this case the complex appears black. When the complex absorbs whole white light, the complex appears black. Number two, the complex may reflect or transmit the whole light. The complex may reflect or transmit the whole light. In this case the complex appear white. Number three, the complex may absorb some of it, partial means some of it, or may reflect then the remaining light, and it means that color is going to be formed. Color is produced in the substance due to the absorption or emission of the photon in a visible region of the spectrum. So if you see the visible region, we can see our naked eye. So the color is going to be formed here. So students, we are going to finish here. Then I will explain in the detail all these things in the next lecture. So today we done the coordination number 2, 4, 6. Their structures and their examples I told you for 2, for 4 and 6, and how the colors are going to be formed. So I told you about the colors. Then I will give explanation. Examples are given. This is a very important chapter. We are doing about the transition metal complexes, D block elements and F block elements. So thank you very much.